All right, everyone. Well, welcome. Why don't we get started here? So welcome to this session on preserving and replicating computational model data. We're happy to see so many of you on, and this is going to be a panel discussion and hopefully a lot of good opportunities for interactivity and for all of you to provide questions and input as our speakers get going, and then we should have a good chunk of time towards the end for some general discussion. I'm going to do a quick summary of what we will be talking about today in terms of our panel. I'm realizing I left somebody else's email on the slide, but that's all right. So I'm Matt Marinick from NCAR, the National Center for Atmospheric Research. I'm going to do an introduction, which I'm doing right now, and then I'll talk about a project that we have about a year into a research coordination network project focused on this topic of model data output and how to preserve and replicate those. And then we will have a set of comments from some experts in this area, Gary Strand, Peter Fox, and Mark Parsons. And these are not necessarily the titles of what they're talking about, but sort of an overview of the general topics that, as we were preparing for this session, these folks will be discussing. In the session description, there are a set of questions, and I believe I put them in the notes for this session as well on the conference platform. There's a set of guiding questions around computational data, how they should be archived, how they should be dealt with and cited, and so on. And we'll get into those specifically in the discussion. And the comments of these panelists will be related to those topics. So I'll do fuller introductions for each when we get to their respective talks. And as I said, we will have open discussion at the end. We should have a lot of time for that. Please feel free to be putting questions in the chat. If we don't get to them, I assume you can raise your hand or jump in audio-wise. And we will have a little bit of time after each speaker for questions for that specific speaker. So I'm going to now jump into my slides. So the motivation for this session comes out of a research coordination network project that we're working on right now. And this is called Determining Best Practices for Preservation and Replicability of Model Data. And the PIs are myself, Doug Schuster, and Gretchen Mullendor. And all of us now are at NCAR. Gretchen just started at NCAR. She's been at the University of North Dakota for a number of years before this. And as I said, this is funded by the NSF EarthCube program. So the motivation for this, when we wrote this proposal a couple years ago, was that as these open access expectations for data have been evolving over the past 5 to 10 or even longer years, there's lots of requirements coming from publishers, coming from funders, and lots of details to those requirements, and lots of support for those requirements from repositories. The data management requirements for simulation output have been not as clear in a lot of these guidance documents. AGU actually recently updated theirs within the past about a year or so, which I think are quite a bit better than they were when we wrote this proposal. But still, there's inconsistency, and it's generally been a bit of a moving target for folks who are working on computationally intensive data, simulation-based projects. So we wanted to get some coordination around that topic. And the starting point for this project is we knew the answer wasn't preserve all the data. There may be some kinds of projects where that's important, and I'll talk about that later. But for many of these computational projects, it's too expensive to save to preserve all of the output and make them available in repositories because they're just too big. And there may be lots of steps in a workflow for computationally, simulation-based projects where some of the intermediary products are not actually that useful to understanding the output findings from the projects. So it may not be the case that all of the outputs need to be saved in order to use the resulting findings. So we started this project about 1.5 years ago. We did 2 virtual workshops last year, and we've done some additional development of documents and engagement over the past couple months at AGU and the American Meteorological Society meetings. And so provide a few of high-level outputs from those efforts thus far. The main kind of outcome or output so far is a kind of a draft rubric for helping people go through this question of what model output to preserve. I'll show you a little bit of a snippet of this on the next slide. But the goal of this is to help people with this kind of question or task, to assist a researcher in determining what simulation outputs should be deposited into a fair, aligned community repository to communicate knowledge. So we're focused on the community repository aspect. We're not as focused on what people might save on their hard drives, or if they're using a cloud system, what they're doing there. We're focusing on what should be shared in a kind of fair sense to communicate the knowledge of that finding. So here's a small snippet of the rubric. The way it's organized is on the left, you have these descriptors. And this came out of lots of discussions at those workshops about sort of important factors that influence decisions about what model output one might keep and, again, preserve in a long-term sense. So these descriptors then have definitions, and then on the right, you see kind of this spectrum of classes, kind of cases, so to speak, associated with these descriptors that suggest preserving either less output or more output. Just to look at these two quickly, the computational cost of running the simulation workflow. In class 1, if there's a small computational cost and no special platform needs, then preserving less output might be a good outcome because it's easy to regenerate, and both easy and cheap to regenerate. Whereas for large scale, perhaps HPC type class systems that are difficult to access, or at least require special access and have large volumes of data, maybe preserving more is useful because it's difficult to recreate those. In the second example, a model source code availability, sort of a similar set of ideas, but in the class 1, which would be suggesting preserve less output, is a community valid model. It's highly accessible, broadly used, broadly understood. So again, regenerating the data, or at least analogous data, be very easy. And then on the right side, there may be cases where the source code is difficult to acquire. And we had cases such as people from some of the military research agencies unable to share code due to national security reasons. And so the source code is just literally not available for anybody outside of their organization. And so then sharing more data is useful. So there's a whole suite of these descriptors, I think around 18 or so. And they kind of are grouped into these themes. I'm not going to run through all of these, but what we're trying to capture with this is having gone through all of these descriptors, one might come up with a sort of an aggregate score across that class 1, 2, and 3 that would suggest either archiving more data or less data, depending on the characteristics of your project. So how accessible is the data in the workflow? And what's the cost, as is shown on the bottom here? And then maybe how easy is it to reproduce the features that you're actually studying? So that's the idea behind that. We've had a couple people take this, people from our workshops, and kind of make adaptations to it, and are using them now actively in their own organizations to help with some of these decisions. And we're excited for that to happen as well. So you can get the first version of the rubric at this model data RCN URL at the top. Right now we're in this sort of stage of engagement. So we've had some meetings, as I said, at AMS and the AGU meeting, and now this one. And we're planning potentially going forward additional workshops in the next year to be determined a little bit on what those topics would be, but to refine this, to test it out, and to check out other themes that have come up in some of our workshops. We do have a mailing list, and you're free to contact either myself or Doug Schuster at the email here if you're interested in joining the mailing list for updates on this project. So that's what I have. Happy to take any questions for right now before we jump into our next speaker. And if they're in the chat, I can't see them right now, so somebody could maybe say those. All right. So hearing none, we'll turn it over to our next speaker, which is Gary Strand. And I'll do a quick introduction of Gary. Gary is a software engineer at NCAR here in Boulder. He works within the Climate and Global Dynamics Lab, and he's our noted expert in climate model simulation data. He specialized in climate model data management, including archiving, access, metadata, and so on, as well as data analysis and visualization, and definitely deals with data at the sort of big data scale, terascale, and now even into petabyte scale. So Gary, if you want to jump into your presentation.
Thanks, Matt. I really don't have a formal presentation because I'm much more interested in the panel discussion. So I just went through, let me give you a little bit of background. So yeah, I'm the quote unquote official CSM data manager, and what CSM is the Community Earth System Model, which is our NCAR's flagship climate model. And what we do is we use it and distribute the code and the data, but we use it to simulate the Earth's climate, obviously things like present day climate and future climate, but also, climate of the ancient past, sensitivity experiments where we tweak various aspects of the model to understand how the model works and how it responds to changes in input and that sort of thing. And I've been helping distribute the output from CSM and its predecessors for quite a few years now. And so I have a fair amount of experience with what our scientists expect and what they value from the model output and what our users expect and value from our model output. And one of the key elements that comes into distributing our data is, it's a very person-intensive and labor-intensive process. It can be as complicated as model development itself, but I'll mention that a little bit later. And I'm interested to see what other participants in this session have to say. But just to go through some of the questions that were put up for us to take a look at. So we determined that
But I'll just sort of give you a look into sort of the first screen that you would see for using that services.
Sorry, Dan, are you on? I think we're getting some noise from you. Go ahead, Gary.
Okay, yeah, sorry about that. But anyway, so how do we determine the value of our model output? Well, initially, when we decide how much we're going to save and what we're going to save, the scientists whose scientific interests are going to be addressed by the model simulation in question usually come up with an initial list of output. It typically just defaults to what the model saves, but then we also will adjust that. If the scientist in question is interested in looking at, say, atmospheric rivers or tropical cyclones or that sort of thing, we will likely increase the output of high temporal frequency, 3 hourly, 6 hourly, that kind of data. If they're interested, obviously, in ocean processes, we'll increase the amount of ocean output. But then after the run is done, we can analyze the usage of the outputs and make a determination as to whether or not that particular output from that simulation was actually useful or not. As to be expected, 90% of the data, or 90% of the users use about 10% of the data. I mean, the standard things like, surface temperature, precipitation, wind stress, ocean currents, sea ice area, sea ice fraction, net primary productivity on the land surface, the crop mixes and that sort of thing from our land model, the general basics of what a climate model does. And those are typically very popular with our user community, but there can be and sometimes is a rather long tail of potentially high volume output that is used by only a relatively small number of people, but is absolutely critical to their research. So trying to balance between what's popular and used by everybody, but what's absolutely critical to a relatively smaller number of scientists and researchers, but like I said, is absolutely necessary to them. That's kind of a tough balancing act. And the CSM, we do have a data management policy and procedure document, and that allows us to basically over time reduce our data holdings. So theoretically, by the end of say 10 years or so at the outside, we are only keeping a small fraction of what was originally output. However, as the model evolves and so forth, we typically increase the geographical or the spatial and temporal resolution of our outputs. So 10 years after a model run is done, we could potentially save the entire thing because by current standards, that volume is very small, a few terabytes at most, whereas now we operate in the petabyte range on a regular basis. So, but on the other hand, managing all this old data, which may have some quirks, it may have some strange idiosyncrasies to it that the model has evolved since then, is no longer relevant necessarily or has been corrected. that makes it a really difficult situation to manage these old model outputs. That's one thing we're still trying to figure out. In terms of how we pay for this stuff and currently and fund it, at least at NCAR within CESM, for certain classes of simulations, particularly community ones that we share with the entire community, the storage costs of those are borne kind of internally from base funds, if you want to think of it that way. However, NCAR is starting to has begun a system where people will put in a request for data storage, and if it's not covered by quote unquote base funds or something equivalent, there will be a storage fee that will have to be accounted for and budgeted for in the proposal in question. That's kind of new territory for us, and we haven't quite figured out all the ramifications of that and the potentially somewhat detailed or intricate ramifications and outcomes of that. So we're still exploring that. One other thing I want to mention is that on October 1st, NCAR's longstanding tape archive system is going away permanently. And so what I've been doing for the last few months and continuing through this year will be to pull off all of our archived on tape data and putting it into our new, they call it campaign storage. It's our new archival system. It's all on disk. And so that gives us that has given me and our project an opportunity to really make a good assessment of what's valuable and what's not, and what to keep and what not to keep. And unfortunately, our old tape archive, our tape archive system from our holdings is roughly 20,000 terabytes or 20 petabytes. We only have storage for about 10 currently. So we'll have to figure out, what have to keep and what have to let go. And there's some interesting aspects that come up with that. And one of the other questions, the next question is, how do archives maximize the utility of the model-based data? Well, the thing that has worked best for us is to make our output and our data as compliant with the best standards available to us, which is at this point, the CF conventions. And it's one of my bigger tasks is to improve the CSM model code itself so that it actually dumps out all this nice data with all the accompanying metadata and so forth natively from the model code itself. Currently, it dumps out the data in a not particularly useful format for users, but does help the model perform well in terms of efficiency. And then as we take that, the raw model output and improve it, we do add metadata and rearrange things a little bit so it makes it more useful. But one of my longer term goals over this next year or so is to work with our model developers to incorporate those improvements to the model or to the data output itself so that it can more easily meet the needs of our users without an intervening step, which can take additional time and effort. Model codes, the model code itself, the CSM source code is on GitHub, and it has been for quite some time. It's freely accessible, freely downloadable. We have probably roughly 600 to 700, maybe even up to 1,000 people have actually downloaded the models, and a fair number of them have used it in their own personal research, perhaps at their site or on their university cluster or something like that. Although one interesting aspect of that comes up in relation to model output is we recently got a request of a group of people that have downloaded CSM and run some experiments, and they're interested in having NCAR potentially host their output here locally at NCAR instead of at their university or wherever it is there are. And we really don't have a policy in place for that. So that's something interesting that's cropped up. Does NCAR want to be a fair repository for all CSM output, regardless of whether or not it was run at NCAR or at another institution or at a university? That's a question we haven't figured out the answer to. So that's another kind of thing that's come up, and one of the aspects of what can happen when you have a community model that's open to everybody. And then lastly, citation work. We do assign DOIs to certain model simulation outputs. all of our CMIP6 runs, which if people are interested, I can talk about that. Those all have DOIs. We didn't assign those. The model code has a DOI, but we haven't gotten to the point of assigning DOIs to like the model analysis codes or scientist or analyst codes and things like that, or their outputs. That's another area where our policies and plans just aren't up to where the standard practices are in this community. So I see there's a few questions in chat. So what is your policy on what to keep and what to discard? Well, a data set that has never been used, that's an easy one to discard. And we do tend to keep stuff. I'll go into, if there's interest, I'll talk about the policy a little bit more. But we do, like I mentioned earlier, we do have kind of a ramp down. So after a few years, we don't keep as much as we did originally. We typically get rid of the stuff that is perhaps less used, an intermediate product that isn't really necessary for the final product, that sort of thing. Let's see, a couple other questions. Yes, we do have citable DOI for the code. Does your metadata for model output point to the version of the model code that generated the output? For our CMIP6 data, yes, we did specifically point to the model configuration that was used for that specific simulation. That's encoded in all of our netcdf files. How long do you plan to retain the model outputs that now have a DOI assigned to them? That's a good question. I would love to be able to tombstone some of our older output, but that will likely end up being our solution. We have data out there that's more than 10 years old, in some cases pushing 20, and it's still available and still downloadable, but it's becoming a management headache to remember all the kind of details that went into that stuff. So chances are that's going to be eliminated relatively soon. And
Gary,
one last question, what is the growth rate of your model outputs? For CMIP5, we generated about 1 petabyte of data. For the current CMIP6, we generated a little over 2. So figure a doubling rate of every 6 to 8 years, something like that. So that's a rough guess. But I think I'm getting pretty close to my time here. So
yeah, Gary, can you hear me okay?
Yes, I'll shut up and let other people go.
Well, there's one question from Madison that you didn't address.
Oh, I see that, okay.
Maybe a little bit up higher. Public repositories generally assume the data associated with the DOI will persist. Can you maybe address that one and then we'll move on?
Yeah, we may do exactly that. Just make note of the fact that these data are now obsolete or have been rendered, like I said, obsolete, and just leave it at that. One quick thing though is one of these nice things about these big model intercomparison project, these MIPS, is that our outputs are replicated across the planet. So theoretically, we could eliminate our local copies and rely on these global replicas to keep our data maintained. But there's a little bit of a risk there. Plus, we do like having local copies. So I'll just leave it at that.
Great. Thank you, Gary. Clearly, you got a lot of thoughts going here, so that's great. So let's see, Peter, I think I have you next on the list. Peter Fox, I'm sure many of you know him. He's a professor in information technology and web science at Rensselaer Polytechnic Institute. And he's been the past president of ESIP, involved in many things in the ESIP semantic web community and other communities. And so, Peter, I'll turn it over to you.
Thanks, Matt. While I am trying to find my slides, I've just got a few slides here just to give some framing for what I want to, what I was asked to talk about, and it really is the journal perspective. Hang on, can I multitask? This is the question.
While you're doing that, Peter, I'll just say we did ask Peter to join this session because he's the current editor-in-chief of the AGU journal Earth and Space Science, and has in that capacity dealt with a lot of model data from the editor side and dealing with authors who are working with model data. And so that was one of our reasons for asking Peter to join this panel.
Yeah, okay, sorry guys.
You want me to go, Peter?
Hang on, just give me a sec.
All right.
Too many windows. Do you want to hear about astrobiology? I've got that slide deck up pretty easily.
Keep that around for the end of the panel if there's dead space.
Hey, Mark, why don't you go ahead while I work this out? Thanks.
All right, no worries. So Mark Parsons, again, I'm sure many of you know him. He's had many roles in the ESIP world as well. He's a couple of the reasons we asked him to be on this panel as well is he's currently the editor-in-chief from the Data Science Journal, and so has, again, experience from that side in various ways. Also, he's the current chair of the ESIP Research Object Citation Cluster, which is looking at citation for lots of different types of resources. And so we thought Mark could talk about potentially citation and identification of simulation-based work. So go ahead, Mark.
Thanks, Matt. Can you see my slide?
Yes.
Okay, so I'm going to talk about citation and really what citation means. And so I'm really going to only hit on the last question, the last prompt that Matt provided us. And when thinking about Earth system models, I thought it might be actually useful to start with the humanities. Some of you may be newly familiar with this marvelous young poet, Amanda Gorman, who recited at the presidential inauguration last week. And it's a poem which I hope inspires our country to follow its better nature and will be remembered for many years to come. And in the spirit of poetry, she subtly and also directly alludes to work from others. And I was struck that in an interview on CNN afterwards, she states emphatically, "I cite my sources." And she does. In the interview, she was talking specifically about Lin-Manuel Miranda and the popular musical Hamilton and how she was citing that, but also some more general references. But of course, when she says in the poem, "For while our eyes are on the future, history has its eyes on us," she does not follow it with Miranda et al. 2015. She tweets it. And I think that's actually a legitimate citation. And so the citation within the context of the poem is more subtle and I think tacitly understood within its context. And it'll likely be recognized even after Twitter is forgotten. But here with Twitter, she provides fair credit. It's reasonably precise. And she even uses identifiers in the form of Twitter handles. My point with all of this is that first, citation means several things. And second, that it's interpreted very differently in context. And I think that's true in the sciences as well as in the humanities. And so what does that mean in practice? Well, first off, ESIP uses this definition of data citation, and within the citation cluster and within the stewardship committee, and I would like all of ESIP to adopt this definition. It comes from CODATA, and I think it applies equally well to code and other types of research artifacts. But the idea is that data citation is a reference to data for the purpose of credit attribution and facilitation of access to the data. So the reference, meaning the precise thing that I mean, the exact thing, and access, the location of the thing so I can get it or I can go to it, or maybe how I get there so I can send my code to the data in some case. And then credit is the most challenging, and it's extremely contextual, but sometimes really important. Sometimes it can inform provenance. It can have indications of what the data quality are, the level of peer acceptance, et cetera. And then there's these other sort of implied things that citation does. It may imply some level of authority. It may imply, that you can get a sense of impact or provenance. And so this may all sound a little abstract, but I think it's just really important to be clear about what you mean by the word citation. We use it very loosely in a lot of different contexts, and we need to be thinking about what we really mean. So with that, let me turn to Matt's question. How should citation work for model-based research? And basically the bottom line is it depends, and you have to consider the use case and really separate out all those concerns out that I was talking about: credit, reference, et cetera. And I think this actually might fit well in some sense with the rubric that you're developing, Matt, as you were putting that forward, as saying that, you know, you can start to tease out, I think, some of these use cases. So just some examples: citing precise subsets of this massive model output. I would like to believe that the RDA dynamic data citation recommendations are the way to go. We found, I'm a co-chair of that working group, and we found it's not as hard as it seems, and it can be done incrementally. And we have a paper in press. We just submitted it to Harvard Data Science Review. I don't even have it up on a preprint server yet. But it spells out, you know, a lot of different scenarios of how this works. And we'd really love to see this, how this scenario might work with, you know, massive model output. Other sorts of citation scenarios, you know, the input data, that's going to depend to a certain degree on what we're talking about. You know, is it the original input? Is it reanalysis? And again, machines and humans are going to have different needs. The machines are going to need to know exactly what data were input, of course, but humans may need some measure of authority or quality. You know, this is the Hadley climate data. You know, this isn't just any old climate data. Others, you know, similarly, parameterization. This is often a, you know, there has to go through some sort of scientific vetting. You may actually just be citing a value or a range that's actually in the literature, that's gone through peer review and has survived the, you know, sort of the test of time. And then code is going to, I think, going to be even more complicated. And I think Gary alluded to some of this. And there's, you know, there's the model code itself, and it sounds like, you know, they have DOIs for that, and that works okay. And there's a nice connection actually between Zenodo and GitHub that helps facilitate that. But as Gary indicated, you know, there's the processing code and all these other codes. And I think in some cases, you know, it may not even be worth citing. Or you recognizing it in a different way, or you're only looking at the reference aspect of it for the machine to work. But ESIP has software citation guidelines, which should be helpful. And Force 11 has a working group that has really been looking into a variety of different use cases, because the citation of code, you know, is so contextual. And so this might be another use case to throw into that mix, or multiple use cases. And then finally, I thought, you know, one question of Matt's that I also relates to citation is, how should model codes be made accessible? And I don't have a good answer to that, but however it works, there will need to be that precise identification and location aspect, which is, you know, fundamental to citation. I include a number of references just to help be useful. And, you know, since I'm talking about citation, I wanted to cite things. And I'll have you take any questions.
Great, thanks, Mark.
I can't see that. I can either leave my slide up to go see the chat, or I have to, or maybe you can read it.
I'm looking at the chat now. Anybody want to ask Mark a question at this point? And we had some comments in the chat earlier, Mark, coming up about landing pages, and you know, Madison's question earlier about sort of deprecating data and continuing landing pages being available. Is that same discussion being had for code? I mean, code can be just as challenging to understand 5 or 10 years later as data.
Yeah, I believe so. I haven't been deeply involved in the code citation aspects. If Dan Katz is online per chance, he would know much better than I. And I think, you know, as a general principle, yes, but then with things like the Journal of Open Source Software that Dan is the editor of, they perhaps have more requirements for persistence, since, you know, that's more of a formal journal article.
All right. Any other questions for Mark? We'll have Mark available during the chat as well.
Okay, thanks.
All right, thanks, Mark. So Peter, we'll go back to you then.
All right, hang on, take 2. Yes, yes, I found it. And And now you are seeing my slide.
Yep, can you make it full screen?
Yep, you bet. Righty, thanks for bearing with me there, and thanks, Mark, for stepping in as usual. Just to rewind, my charge here is as editor-in-chief of the AGU Earth and Space Science Journal. I've been in that position for two years now, and so I just wanted to, you know, in case you've forgotten what I look like, I'll keep my camera off to keep the bandwidth okay. Just a little bit about Earth and Space Science and why it bears on this question of model data. So gold, open access, a couple of different article types. But really the two things are the second and third bullet on the left here, which is Earth and Space Science is involved in a lot of special collections. And what that does is it opens up the landscape for authors to publish works that are not just sort of the pure science results only, but they're data sets, models, as you'll see in a minute, experiments, techniques, field programs, algorithms, and so on. And so we have collections, and we also, when an editor from another journal finds a paper that might be really interesting, and we're getting a lot of model intercomparison papers, they say it doesn't really fit because there's no new results, but the results are, you know, could be interesting. Then they pass it over to our journal, which is become a very popular venue. And so what that has introduced for Earth and Space Science is that there's complications for both data and software. So because we welcome transfers of articles as well as the collection side, our primary metric for consideration and acceptance is usefulness. And I talked about this at AGU last year. And so potential for future use, and especially this is where model data is potentially interesting as well, over new science results, or even impact or likelihood of citations. And this is another consideration for how I think about how the model data is referred to, let me just say that, and how the data is made available from models. And then the bottom bullet really is in principle, this means that the papers are published quite regularly on negative results, especially from models, as well as other things, data sets, algorithms, models, sensitivity and evaluation studies. And so I've had to take a series of editorial actions as the popularity of Earth and Space Science has increased for model-based studies, and I'll just call them the CMIPers, especially, but also the evaluation studies, the comparison of reanalysis data sets to models and so on. And for a journal, the problem is a subset, and I think Mark referred to it, Gary might have as well. And the task really is related to referring to the data that's represented in the paper, not the body of work as a whole. And this, Mark mentioned dynamic data citation, and I totally agree that it is a mechanism, but boy, you'd be surprised how few authors or repositories have the capability or the wherewithal to implement something like that. What I get instead is item number 2 is, oh, you can go find this, all the CMIP data at the Earth System Grid Federation site. Pretty much that's all they do. And of course that's useless. It's completely useless. There's no ability to find specific model runs. And as was mentioned, some have DOIs and landing pages, but even then within those CMIP runs, it's not always completely clear what has been represented in the paper. And so we tend a little bit more to a more of a narrative description. In other words, give us a findability criteria, a location like a URL over a citation, and then additional search criteria, selection criteria, data product types, time ranges, variables. And so sometimes the references to data availability can get quite long, but they turn out to be incredibly useful. Had many authors and readers give feedback, say, wow, this was cool. I used this paper for my class. I could give it to the students. They could go off and actually retrieve this data and redo some of the analyses or verify the analyses, whereas previously they couldn't. And then that goes directly to access, so it's F and then A. What are the restrictions? Do you need a login? Many places you need a login. Do you need to comply to a license or other copyright considerations? And do you need resources to retrieve some of this data? So what this has resulted in is more detailed clarification on fair implementation in relation to the data statements and the data policies. And at the same time, my intent to have strict enforcement of data statement compliance. And we have mechanisms to do that. A lot of papers are getting rejected until they come even close to complying with sufficient availability of the model data that can be then sent to a reviewer. And that means there's a lot of interaction with authors, a lot of education going on. And in addition, then a lot of guidance is needed for editors on data decision criteria and compliance. And one of them that I just want to mention a couple of things. So what's on the horizon related to especially analysis, model data analysis, is that we just have our first 2 papers on papers that we publish using Jupyter Notebooks as the mechanism, and they are both about to get accepted. And so I think there's a potentially very interesting model for rather than citing all the analysis software and so on, you just provide an environment where the analysis is actually right there. So that's one. Stay tuned for that. The other thing is that the AGU data policy only requires persistence for 5 years. And I want to make that clear. Most journals have a slightly different policy, but it's certainly not persistence for a very long term, 5 years at the most. And then lastly, in terms of codes, we have all the things that Gary mentioned in terms of sometimes codes are of open source and community, and often they're, the Navy. So we've come up with a series of mechanisms for talking about the codes, all the way from including parts of pseudocode, including workflows in the paper that don't reveal the actual physical code itself. And that has gained a lot of acceptance from authors. And I'm currently working with AGU, Shelley, Stoll, and so on to insert some of that in the AGU policies. So what our data statements start looking like, things like this one. This is a little bit of a mixture of the model, outputs of models, but still when they're making comparisons with observational data sets, you get stuff that you can see in the bottom here, which is again top level websites that that really don't comply with my criteria for the journal. So that's it. That's all I wanted to say. Maybe I'll just leave it on that slide and see if there are any questions.
Thanks, Peter. We do have one here from Rama, directly following on your comments about the 5-year persistence. I think the question here is, if you talk about the persistence for 5 years versus potentially reassessing continued persistence at some interval, maybe 5 years or less or more. So what is that 5-year? Is there anything that happens at that 5-year mark?
The 5-year designation is the expectation from the AGU as a journal and Wiley as a publisher that that is the minimum required for authors to agree to, that at 5 years. They, of course, now in the case of model data, you have a relationship between the authors and where the model output might be placed. That is completely ignored in the AGU process. So it's not that it could go away, but it's the expectations that if someone was to come along in 5 years' time and say, I want to access this model data, then it would be there. And if it wasn't, then the onus would be on the authors, not the model repository, to provide that data. If that answers your question, Rama. But
Thanks, Peter. All right. So I think we're moving now into the general discussion. I think that's been our panel. And thanks to all of speakers. I think they put a lot of interesting issues on the table here. I guess we do have one more question here from Robert McGuinn. Is strict reproducibility, as in Python notebooks and hosted data services, the gold standard? Want to comment on that, Peter?
Yeah, no, it's not. Definitely not. No. Transparency is the gold standard. Transparency in terms of what you did, but the whole notion of strict reproducibility is really a second consideration for the journal. So reusability, repurposing, all the other RE words that are common are much more important, or equally important, but transparency in terms of a piece of scientific work is our gold standard for sure.
Thanks, Peter. I think that dovetails a lot with our experiences in our project, in our workshops, especially the first one. We did have some sort of discussion points about kind of bit level reproducibility, which is often discussed for simulation data. And that was pretty quickly pushed aside by the modelers for various reasons. But I think in favor of this idea that understanding, transparency is sort of more useful and practical than anything really sort of at the bit level. All right, so I'll turn my camera back on for the sake of it. So we have now some time, and I'm going to stick some of the questions that we had for the panelists into the chat here. And we now welcome your input on any of these. I think a number of you were already providing some input in the chat on potentially how you would deal with this, but I think we're interested in hearing from other folks in other organizations how you have dealt with model data, model code from an archiving and reproducibility or replicability perspective. So we have a question here from Bruce, which I'll read out, and I'll open it to any of the panelists who want to address this. What is the view of best practice around identifiers for specific versions of data? As an example, we have a soils data set that gets updated regularly, mostly as an append operation. We have a DOI for the data set. How to best enable people to indicate which specific binary version they got? Anybody want to address that one?
I can take that one. So I thought it just maybe as to introduce my answer is I thought it was an interesting contrast between my presentation and Peter's. Mine was sort of the ideal, which we talk a lot about in the ESIP, and Peter's was, the very real practical, actually how it's working on the ground as we sort of strive towards the ideal. So to answer your question, Bruce, the ideal is the RDA dynamic data citation recommendation. That said, people have been reluctant to take that on. And as I said, we've been finding it's not as challenging as we think it is. And it's basically what is good archival practices in the first place. But recognizing that that's not going to happen overnight, then this concept of minor and major versioning can be useful. And we talk about that some in the ESIP data citation guidelines, where you might cite your soils collection, and then you might cite you might provide a narrative, like Peter said, in the what subset you used, that you might just do that in your data availability statement, or you might include an access date in your citation. So that gives you a sense. So even though you have a persistent identifier, the access date constrains that at some level. And also the ESIP guidelines specify that you should always include a version in the citation. So if you're doing versioning and you're making a difference between a minor version and a major version, that should be specified in the sort of the textual piece of the citation. A lot of people argue that, you know, anytime the data changes, you should change the identifier, but that's simply not practical in a lot of cases, especially for streaming data. So a lot of places will do a DOI for the collection, and there may be and when there are minor changes, even, you know, changes in past data, not just appends, that doesn't get a new DOI. It's just described in the documentation, and you can try and include that minor version in the descriptive, you know, the narrative part of the citation, you know, Wilson et al. Cool Soil Dataset version 3.3. So it's kind of a hack, but again, it's like what Peter was getting at, you know, it increases the transparency, it increases the accessibility, you know, it's not perfect for machines, but at least humans can sort of work their way through it.
Thanks, Mark. Gary, I wonder if you could comment on versioning in CESM, and is that something you deal with? And if so, how do you deal with that, either from just a management point of view or from a identifying and citation point of view?
Well, we typically don't append outputs. I mean, we don't do things like, you know, this use case. So we've not had an issue with, you know, needing to redo DOIs to accommodate new data. That's not an issue for us. I do try to make it clear, as was mentioned earlier in chat, that what version of the model and what, if possible, the configuration of the model that went into the data that we're providing. So that's about the closest we get to versioning in that sense. But since we don't continually update our outputs, not in the same sense, that's not really an issue for us in that kind of version.
Thanks, Gary. All right, so we have a comment here, a couple comments from Nick talking about his experience at Magic database. Have a DOI for each version, but all DOIs for a version go to a landing page for the data set that highlights the most up-to-date data set. So that's sort of a combination of what Mark was talking about. Thank you for that, Nick. So Peter has a question for all of you, or I guess he has a comment. How to determine the value of computational model outputs? Who makes this determination? The reviewers. Peter, do you want to comment about that?
Yes, Matt, unless it takes us off track from the previous DOI discussion, we can come back to this one. I was just working through the question, so I'll leave it to you as moderator.
Go ahead, Peter.
Well, it is, you know, the goal in the review process for many journals now is to determine value and, as I said, usefulness. And that's why the availability of data of any sort is really fundamental. So we get the first order assessment of value from the reviewers, and then we get the second order assessment from people who read, and then, you know, maybe eventually cite. But remember, value and citation count are not necessarily directly related. You know, the old, if you save one life and only one person reads your paper, then the value is pretty much infinite. And so the way this turns out actually is, you know, Mark's comment about putting citations on social media is that in the review and editorial process, we highlight what we consider to be significant works that are deserving of additional promotion. And these are editors' promotions, these are tweets, these are editors' voxes, these are EOS articles, and that increases the dissemination and availability. And a lot of those additional promotions are related to modeling studies, increasingly to modeling studies. And I think we're going to see a big ramp up as the CMIP6 papers also start to come out. And so, you know, it's a little bit of a different mechanism rather than the repository or even the model developers determining, you know, value. It's really the consumers that are having a big say in this.
That connects to what Gary was commenting on in some of his responses about, you know, usage is an obvious indicator of potential value downstream. I think in our workshops, we had some conversations about this, and it's difficult to take subjectivity out of it because everyone will say, of course, my data is valuable and all of it's valuable. But that's not really a practical approach. And sort of trying to get sort of away from subjectivity is difficult, but I think that's where it makes sense to have the reviewers and the consumers kind of, they're indicating value as you said, the first and second cut. Would like to maybe get some additional input on this question. I think this is an important one, and not just for our project, but in general about value and determining from model projects what to preserve. There's quite a few people on the call here who either from repositories or potentially doing modeling themselves. What are some other sort of thoughts about value of model outputs? Got a few chats going on here about DOIs and linking to collections.
Matt, I'll just toss in one and maybe lure Gary into the conversation. And I mentioned in my remarks that negative results, i.e. things that are wrong, turn out to be really actually valuable and useful. Those tend to be the things that are thrown away. And as a result, people can't go and look at and really truly understand why things were wrong, or the conclusions from certain output were incorrect for various reasons. And that, I think, is a loss for how we do science. And again, I come back a little bit to the early career folks who were just trying to find their way. You know, I regularly give assignments like, go take a look at this this data set and this conclusion and tell me why it was wrong. And they learn way more from learning why it's wrong than they do from confirming that it's right. And so I'm curious, Gary, if this comes up in considerations of especially the CSM outputs and different scenarios and so on.
Well, we typically, I mean, it depends on kind of what wrong means. I mean, there's wrong and then there's wrong. I mean, we've had a couple cases with CMIP6 or CMIP6 simulations where the incorrect input data set was specified and a simulation was done and the results actually put into the CMIP6 system, and then the error was discovered, and so we didn't keep the data. I mean, we filed a formal withdrawal request and withdrew the data, not because so much it was wrong, but because the configuration of the model did not follow the requirements for that simulation according to the CMIP6 experiment design. So,
right.
You know, plus, as I keep reminding everybody, internally, just an erroneous model run, we can't necessarily keep all of them just to serve as sensitivity experiments. I mean, I know that some scientists really like it when, you know, let's say we accidentally cut the solar input by a factor of 10 or some, you know, extreme thing like that. Well, the model ran, it didn't crash. Oh, well, there's some interesting results there. But we can't actually use that because it's difficult to distribute that because it doesn't actually represent anything physical. And, you know, it's kind of a tug of war between how much can we learn from things that are wrong versus how much resources do we have to, keep things that are wrong versus what we know is correct. It's not such an easy thing to decide to keep. We can learn from things that went wrong, but there's an upper limit to that. I'll just leave it at that.
Okay, cool.
Yeah, I see a number of comments in the chat now, which is great. I'll just highlight a few of them. So Sarah, I don't see your last name, but made a comment about this question of value, is using the question, how are data being used? So if the output of a habitat suitability model has been used in a management decision, we've ranked that in our decision tree as something that should be preserved. That's a good point, Sarah. Thanks for bringing that up. And that is in our rubric as well. One of the kind of themes that I think I showed on one of my slides is, use in some community activity, like a CMIP or something, where either the data has been created specifically to support these intercomparisons Peter's been talking about, or there's some decision that's being supported by this data. And so those are sort of obvious cases, but it's important to call them out. Audrey has a few comments here and questions. Maybe Peter and maybe Mark as well, kind of from the journal side, maybe you want to comment about this. Is use the same as review? This gets back to the peer reviewers versus the users, and what defines use versus what informs people in a different way.
Yeah, hey Audrey, nice to hear from you. So use and review overlap for our journal especially. Many of the reviewers do actually go in and quote, open up the data, and when I say use, meaning that they do some verification. So that is that's one piece of overlap. But for the most part, I would say it absolutely informs people in a different way, and the different way is the reviewer is looking to establish veracity and support, scientific support, and validation for the material in the paper. Whereas someone who's consuming, the data that's been generated maybe in a different way, has a different purpose. And so I think they're highly complementary, because we all know that it's really hard to track downstream use, because sometimes citation of a paper is one way to do it. But this, and I talked about social media and other types of recognitions of what is useful or valuable. I don't want to get into altmetrics, but altmetrics was meant to be the way to establish the other different types of use and value, but I don't think we're there yet. Curious what Mark thinks.
I agree with everything you said, except for maybe the very last statement. It's seeming to me that altmetrics is pretty useless.
All right, well, I'm glad you said it. I agree. I agree.
I think even within the altmetrics community, there's emergence that, social media is not a good way. Because altmetrics, what do you mean by altmetrics? Yes, we need alternative metrics. We need to measure the use of data and the value and the value of that and the impact of that use in ways beyond citation. Absolutely. It does not look like tweets and so forth are all that useful in doing that. Right. That's basically, and it can be, and as Jessica says in the chat, and it can be totally gamed. Most metrics can be totally gamed, but this one is particularly gameable.
Yeah, if you guys follow me, I'll upvote all your data and your model.
Sounds good, Peter. I'm going to tweet at you next time I publish a paper. All right, so turning to a different topic here from Robert McWin. This is for anybody on the panel first, and then I'd be interested if anybody else in the session has a comment on this. Have any commercial sector solutions emerged for this problem, such as pay to play? And Robert, if you want to jump in with any other specifics that you might have in mind, welcome to do that.
Yeah, which problem?
Well, I think it's the general problem of archiving large-scale data, model data. But Robert, if you're on, you want to comment more on that?
Hey, this is Robert. Yes. Yeah, sure. I just wanted to know if there are any commercial players in this space, and whether or not, in terms of when I say this space, I mean, preserving model outputs for people who really want to, maintain a full record of their model outputs. And are there ways to pay for that?
I can jump in. We have, we've been working with Amazon through their AWS, and if Jeff DLB is in this session, he's the one of the point people on that. One of my big concerns, though, about excessive reliance on private industry for maintaining and archiving our data is that they only do it so long as it's profitable. If they can turn around, if they can sell access to that data or sell that data further down the line and make money from doing it, they'll keep, they'll be happy to take our data. But if the business model isn't there, or if they don't make the money that they want from providing the service to us by hosting our data, then they can they can shut it down in a matter of with very little notice. In which case, if we don't have a replica of the data that we've provided to them, we'll lose all that stuff. So that's my biggest concern, is that these are profit-seeking enterprises. They are not doing this out of the goodness of their hearts. It's not their job. So I'm very excited that we could put a lot of our stuff in the cloud, but I don't think that is that's a be-all solution. I'm very leery of that. Science is hard to make money from, at least at this kind of level. And I'll just say I'm very cautious about putting all of our eggs in that basket. I just want to put it that way.
Matt, can I follow up on what Gary just said and respond as well, without naming any publishers' names? It's pretty easy. You can guess it. There have already been attempts on the pay-to-play landscape in relation to any type of data, not just model output data, and hosting and providing services for a fee. And the community response hasn't been particularly good. The European Union especially has had an adverse reaction. And so I think it's a place to watch. And so I'm not talking about the cloud side of things that Gary just addressed, but at that interface between commercial and intersecting with journals and publishing, there have been forays, and they're currently not, well, let me stop there and not say what I was going to say.
Thanks, Gary and Peter. It's a good question. So there's a lot going on in the chat. I'm a bit behind, but there's a question that I want to bring up because it is an important one. This is from Chunlin Shi. So to summarize a little bit, it's not uncommon to find communities where scientists have won proposals and grants, mainly based on their model codes, and gaining also collaborative credits based on the use of those codes. So it may not be easy to have people share their model codes as open source. I think this is kind of codes as proprietary and sort of your competitive advantage to a certain extent. Any thoughts about this? And it's directed, Peter, to you first, but anybody else wants to jump in on that?
Yeah, hey, Chungling. So one thing that is really important about data availability, regular or model or otherwise, and the narratives is really related to access, and there tends to be this default to open access, open source. That's not the case. That's one component, and so it is very, very acceptable in AGU journals to say this code's not available, but if you'd like to collaborate with us, we'd love to do that. Then we'll share the code, share the credit for the scientific outputs, or if you'd like to buy a license or this or that, or, come and spend some time here and visit and things like that. Those are all completely acceptable options for related to codes and even outputs from code. So it's not, it has to be all completely open and available, but you have to specify what the conditions are. You can't just say the code's not available. That doesn't fly. That absolutely does not fly, because that's not usually true. National security, even conditions under national security, it's possible for certain government agencies to have access to those codes through government arrangements. So this is where we're still coming up to speed on how to give guidance when you make these statements about data and code and models and even instrumentation, same thing.
Yeah, I'd like to add to that. So Shel Gentleman and I chaired a National Academies committee a couple years ago that made recommendations to NASA on how they could move towards an open source policy. And the concerns that you raised were, we did a lot of work with the community, the NASA research community, and got a lot of feedback. And, one of the common attitudes was, this is like my instrument that I patented, and that is my bread and butter, that, by having unique access to this instrument, i.e. the code, that's how I make my living. And NASA, at least, and I think other agencies as well, and we're seeing it in Europe too, are pushing back on that. And so as a committee, we recognize that, all hell would break loose if NASA just flipped a switch and said, all NASA code must now be open, national security and so forth notwithstanding. And so we recommended, and NASA is beginning to implement, and I think other agencies are beginning to explore some of this too, is one has to incentivize this. You have to change the way the science reward system works, and that to prevent people from having that sort of monopolistic lock on certain things. Yeah, I'll do that, Sarah Joda, after this. And so, we suggested, for example, that it provides an additional little add-on, so like NASA used to do educational add-ons. You can get, in addition to your grant, to do an educational project from your research. You could do a similar thing to open your code. The last Roses actually had a place where you could take existing codes and open them up, and then they would pay for you to do that. Also, a lot of need for education and training. People are also concerned that, if I make my code open, I'm going to be responsible for maintaining it. That shouldn't necessarily be true, right? I mean, so I think my long answer is that I think this is going to take a lot of work, but we should try and trend in that direction in terms of just facilitating open science.
Thanks, Mark and Peter. So there's a question a few minutes ago. Doug Schuster, who's a co-PI in the project I presented, about what can groups financially afford to preserve and for how long if outputs are hundreds of terabytes in size. Doug, do you want to say anything more about that?
Well, this was related to the question of preserving wrong results, for the value of seeing what went wrong with the community. I think some of that's a good idea, but then there are financial constraints that are coming into play, as Gary related. For instance, at the National Center for Atmospheric Research, we used to have HPSS available, or mass store system, which was basically a black hole of indefinite preservation of everything. Well, that's not sustainable anymore. So I think that PIs and research groups need to choose wisely what they will preserve for an extended period of time, because now there are financial implications that didn't exist in the past.
Thanks, Doug.
Okay, yeah, so thanks, Doug. Peter here again, because I brought this topic up. One potential filter mechanism or criterion might be, if there's a paper published on it that includes model data that has wrong results, we should keep that data. But as Gary said, there is different shades of wrong, and I'm perfectly happy with folks like Gary saying, "No, we need to delete that." It's probably, if it's been published and someone started to use it and they want to do something with it, well, there's another reason why it might want to be kept. But I'm very happy with the producers having a say in this as well. until it gets to the point where it's disseminated.
That makes sense, Peter. So there's a question from Madison. This was a follow-on to a previous discussion about data used in management decisions. The question is, how do you find cases where data are used in management decisions? I found that to be tricky. Anybody on the panelist have that one answer to that ready at hand? If not, maybe if you have examples, you can put them in the chat if you haven't already.
Madison, what do you mean by like a management decision? Do you mean like someone has taken a company's taken our data and they've decided to invent some sort of product or something like that? I'm just curious.
Matt, I'll just say it depends a little bit on if we're speaking about data more generally rather than model data. And you know, Mark used the use social science data as a lead-in to citation. I find that a lot of social science data often has greater management influence than pure scientific data. But you know, the National Climate Assessment, which is now coming up to number four, I think is a potentially an example to take a look at as an example of output from both models and observing systems and social science data, making it into quote management, or what I read by that is also policy. So maybe Gary has a thought on that.
Or Madison, do you want to jump in here too?
Yeah, I was just going to say, yeah, I was thinking, I guess from a policy standpoint, either like federal policies or state policies, you know, being at the USGS, I think that's important for us to know, but, you know, I haven't necessarily seen where, you know, you can find a DOI referenced in the policy decisions or in, you know, if there's a law that comes out or something, you know, that's usually not what I don't see that.
No, well, it's interesting. There's been research in legal scholarship. The lawyers are very good at citing things, and they may not cite them exactly the way we do. But I'm trying to remember, there was a paper that did some analysis on this, and lawyers tend to be very good citers, and which makes sense. You know, they need to demonstrate evidence. And so in that sense of, you know, in informing law, I believe it is happening. It certainly is happening, you know, in terms of like land management decisions, people are using data all the time, but their citation is not necessarily through a DOI. You know, our water plans in Denver this year come from this, are based on data from SNOTEL and X, Y, and Z or whatever. But I don't, you know, they're not necessarily specifying it, but they're making decisions based on data. I mean, that's happening all the time. Maybe I'm not understanding your question exactly.
Yeah, no, that is happening all the time. It's just a matter of, unless you know about it specifically, tracking those down are challenging. For like, if you're working at a repository level and trying to understand from a general sense how all of your data holdings might be being used.
Yeah, absolutely. Just as an aside, I did data management for a big field experiment about 20 years ago. And the data were initially embargoed to the investigators. But you could request the data, but you had to specify how you wanted why you were using the data. You know, so it's basically so the investigators could see that you weren't competing with them. And then after the embargo ended, we kept that up. We just, you know, it was voluntary. And it was the most revealing thing ever. You know, it was so cool to see, you know, field data from Colorado measuring snow being used to do road clearing planning in Japan. And, you know, it's all anecdotal, but there's all sorts of anecdotal stuff like that. And I think we just need to collect more of it.
Yeah, Mark, I've had the same experience. I've had people interested in using our data for, you know, potential future business investments, of course, impacts on resources. I mean, Denver Water has used our stuff tons, and I'm sure other water managers and like infrastructure type things. But in terms of how they cite our stuff and whether or not we know about it, I actually never thought about that, but that's a good question. I have no idea.
Yeah, and lots of good comments in the chat about some other examples, responses to Madison's question, and then some other sort of points about metrics that are great in there. So we're at about 10 minutes left. There is one more comment that I wanted to get here. We haven't talked about as much, which is from Jessica Burnett, talking about the incentivization system. I think talking about data sharing and code sharing needs to account for quality, not just quantity of code, software, and data being opened up. And I know, Gary, you commented on this in your comments about use of conventions as one way to sort of move towards more consistency and quality. Do you want to talk about the quality issue in terms of how that works for you? And then Peter, I'd be interested in your thoughts from a editor point of view. How does quality come into decisions, maybe reviewers' considerations?
Well, I mean, the good thing about these big MIP exercises is that it does force us to improve our metadata quality, that's for sure. The data quality itself, I mean, we do make some minor adjustments, like maybe tweaking the counter very slightly or something like that. But in terms of the data itself, we just pretty much leave it as is. We don't make any changes to it, because otherwise, that could cause a problem. But we definitely do strive to follow, actually implement best practices, because I look at it this way: the better we do at following standards and best practices, the less work there is for me answering questions from people about our data because we didn't provide enough information about it to them. So that's a powerful incentive to do data quality and do it well.
Yeah, the quality is paramount for the journal. It's the number one thing I ask at the beginning of every editorial board meeting, and that is, how's our quality? The volume's gone up. How's our quality? And it's related to all aspects of the journal, and it applies absolutely to codes, and it applies to model output as well. And reviewers play an important part in establishing at least the quality, let's say quality control, or it gets a little bit fuzzy here. It's not quite like QA, QC, QA, but that's our initial gate. That absolutely is. And there are many papers that just don't make it through because the quality is not there. And this is why it can't just be, hey, the code's on GitHub. There's a lot of not very good code on GitHub. There are less not good codes in more permanent repositories that have been associated with some form of review. And I'll say peer review, whether it's, for example, open source software communities and well commented and well documented codes and well cited codes, hopefully. So yeah, quality I think is really important, and it'd be interesting to see where the quality shows up in other parts of our infrastructure. I think it's in the publishing journal and publishing infrastructure pretty well, but I'm sort of curious how it is elsewhere.
Well, Jessica just made a follow-on comment. Jessica, I invite you to speak as well. I think you made a good comment here. Reviews of quality from a technical point of view, but maybe not from a scientific point of view, which may be a bit more challenging. But if you're on, do you want to comment more about this?
Yeah, sure. Yeah, I guess I just suspect that a lot of the review that's going on in journals, and I'm just guessing here, in journals and additionally at the USGS here, is that we're doing technical reviews. So we are able to replicate results through the code or software or data that's provided in packages. But it's very rare, I think, that the entire kind of scientific, like the whole stack of products, ranging from including the manuscript, the science within the manuscript, the statistical or modeling approach to answer the research question, the code and the model outputs are reviewed, simultaneously or together in the same package. So I'm kind of curious, I guess, especially from the journal perspective, where we can make improvements there.
Thanks, Jessica, for that clarification. So what the journal does is exactly the latter part, the scientific integrity part, as well as certain technical aspects as well, because they're related. But no, when we say quality, we mean integrity, and sort of looked at across what goes into producing a journal article as well. And that's an interesting, having done work with folks like USGS on what it takes to release things. In the release process, I would agree that there's much more technical emphasis on correctness and compliance to standards and have you checked all the boxes and done all this stuff. But there is the scientific, I think the scientific review in there as well. And I think often there's a desire to increase that scientific component within, especially government agencies, in terms of release. But at the moment, the journal process is the one that I know of, for better or for worse, that really insists upon that that scientific quality standard sort of broadly cast. So I don't know if that helps.
And there are a few comments here at the end about the Journal of Open Source Software requirements or criteria for review from Matt Jones and Bruce Wilson. Been useful. So I think, looking at the time, I think I'm going to open up for any last burning questions that people have really want to get off their chest. Otherwise, I think we're going to close up the session here. So it's been really great. All right, some continued comments coming in here. So why don't we close the session though? We're about at time, and I'm sure we're all ready to move on to something else. So first of all, thank you to Gary, Mark, and Peter for some great comments, both your prepared comments and your discussion. I'd like to thank Doug Schuster and Gretchen Mullendor as well, who are the co-PIs of our project and kind of co-organized this session. And all of you for participating. I'm pretty sure I'll be going back to this chat and this video again, because there's a lot of stuff that you didn't even get notes on. It was happening so fast. So thanks to everybody. This is an important topic, and I'm sure we'll have more discussions at future ESA meetings, but hopefully from our project and some of these journals and so on, we'll see some updated suggestions and guidance coming up in the next year or two. All right, thanks everybody.
Ciao, ciao.
Thanks, Matt. Bye, everyone.